So what we're going to talk about, you weren't even here yesterday. So
We're gonna skip both.
we're going to talk about graphing exponential functions. Exponential functions are functions that grow really fast. Example, let's say, you ever received those emails where somebody goes, hey, I'm going to send you this email to send it to 5 more people?
No.
And I mean, it used to be something that used to happen forward. You forward it to 5 more people in there, right? So to figure out, let's say you send it to like 10 people, right? 10 people do this. So how would you figure out how many numbers of email were sent out? It would be what? 5 to the power of what? 10, right? So the function that would best represent that would be f of x equals to 5 to the power of x, depending on the number of people that are forwarding this email, okay? So because if you have 10 people doing this, so that means you send about 5 to the power of 10 emails. It used to be something that people used to do before, or send this to 5 people, or something's going to happen to you today. I never bothered with it because that was scary. Yeah, just change stuff. That didn't work for me.
I got that one.
That never scares me. Right? I could care less. So that doesn't. I'm not superstitious like that, so I don't really care.
I just sent it back to them. I just copied what they did.
Don't bother me. I don't need to send it. Okay. So that's the kind of stuff that we're gonna do today. We're gonna learn how to graph these type of functions, right? Now, an exponential function is always gonna be in the form f of x equals b to the x. B to the x. Okay? Now this function has some specific things that we need to know about. The first thing that we need to know is what is the domain of this function? And when I say domain of the function, I'm talking about for what values does this function exist, right? So if you have a function in the form b to the x, what are the values for which this will exist? I mean, it's on the board. What is it? I mean, not here. I mean, right here. The domain will be what? All real numbers, right? Every single number you put in there, you'll be able to evaluate this function. If you put 3 to the negative 100, you're going to find it. So any exponential function in the form b to the x has for domain all real numbers. Now, the good thing about this exponential function is this. What's the range? When the range of this function is this, when b is positive, right, when there's no negative sign before b, the range will be what? All positive values. Because we're going to have something called asymptote, right? Asymptote.
Asymptote?
Yeah, asymptote is the point for which the function does not cross over, right? So it's called an asymptote. So basically, so you're going to see that a lot in calculus, right? In calculus, you're going to see what we call an asymptote, okay? So you spell asymptote, asymptote, right? So basically, at this specific point, the function is like a limiting value. It's like a border. You don't cross over that, right? So now, how do we graph this function? How do you graph the exponential function? So let's take an example here. If I have I want to graph y is equal to 3 to the power of x, right? 3 to the power of x, we want to graph this. So to graph this, we need to first find the domain of this function. The domain will be all real numbers. And then to graph it, we're going to choose some random points, right? Now, to keep this easy, to make it easy, I always want to choose like this one here, like -2, -1, 0, 1, and 2, right? We're going to graph this, and then we're going to use those as your guiding line to draw the function. So, for example, when x is equal to -2, I'm going to plug it in here. If y equals 3 to the -2, we've already worked with exponential numbers, right? So 3 to the -3 is basically what? 1 over what? 3 to the 2, right? Which is 1 over 9, right? That's 1/9. So this is 1/9. So when x is equal to -2, y is 1 over 9. And then when x is equal to -1, it'd be 3 to the -1, which is 1/3, right? 1/3 here. And then when x is 0, that's pretty 1. So because 3 to the 0, any number raised to the 0 is 1, right? And when x is 1, pretty easy. 3 to the 1 is 3. And when x is 2 is 9. So with this 4 point, I can graph this exponential function, right? I'm going to start by saying when x is 0, y is 1. When x is -2, y is 1, 9. 1, 9 is somewhere right here, somewhere close to that, right? When x is negative 1, y is 1/3. 1/3 is going to be somewhere here. And when x is 1, y is 3. 1, 2, and 3 somewhere here. When x is 2, y is 9. So 2, 3, 4, 5, 6, 7, 8, 9, somewhere here. So the function is going to look something like this. And like I said, we have an asymptote, right? So the function is always going to get closer and closer to the line. This line, y equals x, but it's never going to cross it because that's your borderline, right? It's never going to cross this line, but the function is going to look like this. This is called an exponential function because it's growing very fast. The word exponential meaning something that is exponential growth, something that grows bigger, right? Grows big. So this is how the function is going to look like. So this is 3 to the x. Okay, so basically, if you want to figure out how many emails were sent by 2 people, it would be 9 emails, right? Man, 3 people, that would be 27. If we use that example of forwarding the emails, right? So this function actually gives you that type of like interpretation, okay? Now, as an example, how would you graph y equals to 4 to the x? It will be pretty much the same steps, right? Y equals to 4 to the x. The domain of this function will be what? All real numbers. And then all you have to do is just go through the same step. I will choose the same numbers, -2, -1, 0, 1, and 2. And then draw the function, okay? Now, the problem comes when you have like transformations, okay? Transformations. And today I debated how to teach this, and I think I figured out the best way to teach the transformations. For example, if I have this function here, 2 to the x plus 1, and I want to graph it, right? You guys remember what we did in a very in the second quarter?
No.
Right, some of the things that we did when we transform a function, right? What do you see here? 2 to the x plus 1.
So you're moving to the left one?
Well, this is the function. You're adding it. Are you adding this to the x value or the whole function? Are we adding the 1 to the x value only or the whole function here? The whole function. So we're gonna move on one axis. Up, right? So we're gonna move up. So basically, we're gonna go 1 unit up, right? So that's what we do the transformation. So let's say I wanted to graph this function 2 to the x plus 1, right? I'm gonna go through the same step. I'm gonna erase these here, and I'm gonna do the same thing, right? So I have 2 to the x, and I wanna graph it, 2 to the x plus 1, right? This is what I wanna graph. So what I wanna do is this. There's 2 ways to solve this. We can go the transformation way, or we can go the traditional way of just plugging in stuff, right? So let me use the same values here, right? So let's say I wanna use a transformation. So I'm gonna start with just graphing 2 to the x. Okay, I'm gonna go when x is -2, right? This will be 1, 2 to the -2, which is 1/4, right? And then when x is -1, it'd be what? 1/2. I don't need to do all of that, right? When x is 0, it's gonna be 1. When x is 1, will be 2, and when x is 2, will be what? 4, right? So I can put those on here. I'm gonna put those here, and then we're gonna do something. So when x is -2, 1/4 is somewhere here, right? When x is -1, 1/2 is in the middle, right? When x is 0, 1, x is 1, we got 2 here, and x is 2, we got 4 somewhere here, right? So the function is gonna look like this. But the question is this. This is just 2 to the x, right? But what am I trying to graph?
Plus 1.
2 to the x plus 1. So that means I'm going to choose those key units and I'm going to move them up. How many units? 1 unit, right? So this guy is going to go up 1 unit. It's going to be right here. This one's going to go up 1. It's going to be right here. This one is going to go up 1. And it's going to, now the new graph is going to look like this, right? So this is called a transformation. So you are basically transforming from 2 to the x. You can transform it, right, by just adding 1 unit. Okay, I can do that. Now, what happens is it gets a little bit more technical when we have more than just one transformation. Example, if I want to graph this graph, right, y equals 2 to the x minus 1 plus 1. So how would you graph this? 2 to the x minus 1 plus 1. So how would you graph that function?
You move that, the function you already have over
Right, right? Did you see what he says here? You move that function to the right. Or you can start by doing what first? What would you do here once you graph 2 to the x? What would you do first?
Move to the right.
1 unit
Up 1.
and up 1, right? So you could do that with this. You can move to the right 1 unit and then move up 1 because now the transformation is occurring at the x, right? So if he's up here, when he's negative, we move to the right, and when he's positive, we move to the left. Yes.
What do you mean move to the right and up 1?
All right, so if I have 2 to the x minus 1, right? This is the new function. If I give you this function, you have 2 transformations that are happening, okay? So the first transformation is this. You start by graphing 2 to the x, right? Which we did here. We start by graphing 2 to the x, all right? We start by graphing this function, and then now the next transformation is this. All the x values, what is happening to all the x values?
You subtract them by
1, right? But we say when we subtract, we go to the right, right? So this guy here is going to go 1 unit here. This one's going to go 1 here. This one's going to go here. And this is going to go here. So the first transformation is going to look like this, okay? And then the next one, because we are adding 1, every single one of those that are moved is going to go up 1. That's the last one, right? So you're going to go up 1, without here, up 1, and then up 1. So that the new graph is going to look like this, okay? I know I'm using the same marker, that's why you can't see the distinction. But this is what we're doing. So these you have 2 transformations here. The first transformation is the x values are going to change because this is minus 1, you go to the right. If it's plus 1, you go to the left. Okay? And then the next transformation is the y values on the horizontal. It's called a vertical shift. You're going to shift it up 1 unit. Okay? All right. Now, there's also something else that will occur. And I do want to talk about it, but I'm not sure if I should mention it now or save it for tomorrow, probably today.
I think it's a good idea to save it.
No, I'm not listening.
Everyone
Oh, stop.
Everyone will be more acceptable tomorrow.
Stop it.
You all might be.
All right, you know what I want to do is I want to save this for
Tomorrow.
Never.
because
Next year.
all right, now let me mention this one thing here. All right, so now let's say I wanted to graph 1/2, right? 2 to the x minus 2, like this, right? So here's what I suggest we do here, right? Now, you can see that there's something that's happening with y values here, right?
There's no y.
Well, I'm
Okay,
saying
whatever. There's a y there. Imagine.
y is equal to this, right? So I have 1/2, and the entire function is being multiplied by what?
2.
No, the entire function is being multiplied by what? 1/2, right? So here's what's going to happen here.
So it's 1x.
Now, before we do that, right, let's just go ahead and graph this function again, and we're gonna do the transformations together and figure out what's happening. Okay?
When did multiplication stop being an x?
Because when we added in the s.
Right? So let's start by graphing. We're gonna start by graphing the function that we know, right? Pay attention here because this is critical. Okay? So we're gonna start here, like I said again, I put in 2, I'll have a 1/2 here, and the 1/2 is multiplying the entire function, right? This is the function that we have, and the 1/2 is multiplying the entire function. So we're gonna start again by graphing 2 to the x. Okay? So I'm gonna start by graphing 2 to the x. So when x is -2, 1, 2, y is 1/4. So right here. Okay? When x is -1, 1/2 is right here. I'll put it a little bit up. And then when x is 0, 1 is right here, right? And then when x is 1, we have 2 right here. And when x is 2, we have 4, 3, 4 somewhere right here. Okay? So So this is the function that we have right now. This right here is 2 to the x, right? That's just 2 to the x. All right? Are we good on that? Now, the next transformation is, I'm doing what after that?
Move it to the right.
I'm going to move to the right. How many units? 2 units, right? To the right. So that means this guy's going to go 1 and 2 right here. 1 and 2 right here. 1 and 2 right here. And this is going to go 1 and 2 right here, right? So we have this. Right? This is a new curve. Now, pay attention here. What is happening? I got 1/2, right? That's multiplying all the y values. The x's are not changing, right? Only thing that's changing is the y values here. Does that make sense? Right? So now, what's going to happen is this. When x is 2, right? Now what's going to happen is all the y values are going to shrink by what? 1/2. Okay, so instead of, I ended up here. Now, this guy is going to end up where? 2. In the middle somewhere, right here, right? 2, so this is let me see. 1, 2, 3, 4. So it's going to end up right here, right?
Where it was before?
No. Divided by, multiplied by 1/2. So it's going to end up right here. Right? And then this guy, the x value stays the same, yes sir?
You're not dividing the x by 2.
The y.
By 2.
Yeah, y by 2. Or the y by 2, yeah. The y by 2. So if you're here, 4, right? So this guy's going to go where? Right here, right? So it's going to be right here now, right? Because we have 2 and 2. This is going to go here. And then this guy, because this is here, and then this was right here, now it's going to go in the middle here. So we're going to have it right here somewhere, right? And then this guy here was here. Now it's going to go down here and down here. So now we're going to have this curve. This is what you're going to get, right? Now the reason why this is a little confusing is because I'm not using different colors.
Can you give us colored pencils?
I can give you colored pencils, but all you need to remember is when you do the transformations, 2x to the 2, the first transformation is you move 2 units to the left, to the right. And then next, all the y values are going to be divided by 2. The x's stay the same. I'm going to repeat that again tomorrow so that we can understand. Yes, sir. Yeah. All right. So we're going to redo this again tomorrow because I want to re-emphasize that. Okay. So we're going to do that again tomorrow.
So we're done.
Jack, we'll be back.
We're not done. Cool.
What are we doing now?
You look like you're half dead.